Good morning, ladies and gentlemen, friends and colleagues. Thank you for tuning in for the second part of the new approach to asphalt pavement design. My name is Angela Ratz and I will once again moderate this session and provide technical support if required. And my details will once again pop up on the screen unless we've frozen again. Hopefully not. Peter, can we get that going? I'm sure that will come up. There we go. There I am. So please feel free to contact me if you do have any issues along the way. I won't go through the housekeeping items again, but I will take this opportunity to remind listeners that we would love for you to engage with us. So please don't be shy. Just as you weren't yesterday, please don't be shy today, and keep us posted with any questions or comments along the way. Today's presentation will be led by Peter Bryant of TMR. However, Eric Denneman of AAPA and Jeffrey Lee of ARB have joined us also for special comments and the discussion. A warm welcome back to all three of you, and without further ado, I'll now hand over to Peter to commence the presentation. Thank you so much, Peter.
Thanks, Angela, and welcome back, everyone. Today's session, we've really got three sessions. The first one will be on an improved method for considering axle loads in the pavement design process. After that, we'll go through a fully worked example for a full depth asphalt pavement, which brings together some of the aspects that I'll talk about this morning plus from yesterday. And I'll wrap up with a bit of detail about implementation and how people can provide feedback on the draft technical note. In about 2010, Austroads recognised the need to improve the way axle group loads are modelled in assessing their influence on pavement performance. This was in response to the rapidly growing freight task and trends towards innovative heavy vehicles, often with heavier axle loads or different axle configurations to conventional vehicles. Those issues were leading to increased scrutiny in the way that pavement designers or estimating pavement performance under different loads. So this led to a fairly substantial Austroads research project, which is what I'll be talking about some of that today. One of the most significant outcomes from that research, which was undertaken by Dr. Michael Moffat from ARB Group, was a recommendation to calculate strains under each axle within the axle load distribution, to replace the current approach where strains are only calculated under a standard axle. It's likely that this change will eventually end up in the Austroads guide when it's next updated, but as I mentioned yesterday, TMR is quite keen to make improvements as soon as possible, and it made sense to us to adopt this new method at the same time as we introduce the other changes that Eric and Jeffrey covered yesterday. The method is actually applicable to fatigue of bound materials, so including asphalt and cemented materials. However, in the technical note, we are only adopting it for the assessment of asphalt fatigue, as the assessment of cemented materials fatigue needs to be done in conjunction with some other changes, including to the cemented materials fatigue relationship. And those changes for cemented materials aren't included in the technical note. So I'll briefly touch on some of the background to the method, but for anyone that's interested in further details, there's a number of Austroads reports available to download from the Austroads website, which were all produced under the Austroads project TT1614, Pavement Wear Effects of Heavy Vehicle Axle Groups, undertaken by Dr. Michael Moffat. I thought I'd start just by showing a traffic load distribution, because I do mention this a number of times in the presentation. So just to ensure everyone knows what that term means. On the left-hand side of the screen there, the table is what we call a traffic load distribution. And on the right-hand side, I've just got a list of the 6 common heavy vehicle axle group types. So SAST is a single axle with single tyres, down to the QADT, which is a quad axle group with dual tyres. The traffic load distribution comes from weigh in motion data, and it describes the distribution of axle group loads using a particular road. So for example, if you look at the table on the left-hand side, in say the middle column there, TAST, tandem axle with single tyres, going down that column to the 50 kilonewton load bin, we can read off there that I think it's 3.3% of tandem axles with single tyres are in that load category. So looking down the bottom of that table, we can see that each column adds up to 100%, and the very bottom row gives us the split of each heavy vehicle axle group type. So 36.1% of single axles of axle groups are single axles with single tyres. 30.2% of axle groups are tandem axles with dual tyres, and so on. So that whole table is what we call a traffic load distribution, and that's a key input into the new method.
Sorry, Peter, I'm sure that some of our listeners will be interested to know how widely available this data is for roads in Queensland.
Sure. Yes, so the traffic load distribution, as I said, comes from weigh and motion data. So I think TMR has, I don't know the exact number, but in the order of 15 to 20 weigh and motion sites around Queensland. So the data can come from those sites. If you're lucky enough, you'll have a site on the road that you're designing, but often that doesn't happen, so you need to decide which data to use. That may be just choosing data from a similar site, or we're also working on producing some presumptive traffic load distributions as a separate exercise, and we expect they'll be available by the time this tech note's finalised.
And do designers need more detailed data for this approach than they use currently in the design?
Not really. I mean, the current Austroads approach is really based on using a traffic load distribution as well, but often that's simplified into the factors like ESAs per heavy vehicle. In reality, those factors do come from a traffic load distribution. So in reality, there's not really more data that's required to undertake the designs. Before I get into describing the new method, I'll briefly discuss the current Austroads procedure. The current Austroads method requires conversion of the loads in the traffic load distribution to a number of standard axle repetitions to cause the same damage as that traffic load distribution. And that conversion is done using standard loads. The standard loads are based on the peak surface deflection for different axle group types being the same as under a standard axle. So what that means is that axle groups causing the same surface deflection are assumed to cause the same pavement damage in the current procedure. The conversion of the actual loads to standard axle repetitions is then done using the formula at the top of the page there. So this is for asphalt fatigue damage. The standard axle repetitions, SAR5, equals the axle group load, which comes from our traffic load distribution, divided by the standard load, which is a published value, raised to the fifth power because this is for asphalt fatigue damage. Then the total standard axle repetitions is the sum of that calculation for all combinations of axle group types and loads in the traffic load distribution. It's the number of standard axle repetitions that is then used in the pavement thickness design. The standard loads, as I said, are published and they're in the Austroads guide. They were first developed in about 1970, and that was done by Benkelman beam testing, deflection testing, on a range of unbound granular pavements in Melbourne with both sealed and thin asphalt surfacings. So the loads in that table for the different axle groups were found to cause the same surface deflection. for those pavement types. However, Michael Moffat's research demonstrated that the standard loads actually vary with pavement structure in bound pavements. So the use of deflection as an indicator of damage of bound materials is questionable. Michael Moffat's research recommended that the pavement damage should consider each axle load and group within the traffic load distribution. And two alternatives were put forth for doing this. The first being calculating strains under each axle group, and the second was calculating strains under the individual axles. And for various reasons, which you can certainly read about in some of Michael Moffat's reports, it was decided by the Austroads Pavement Structures Working Group to adopt this second option, which is calculate strains under each individual axle in the traffic load distribution. So this now leads me into describing the new method. At this stage, I'll just step through the main steps of the method, and then when we come to the pavement design example, I'll just go into a bit more detail then to illustrate the method further. The first step is quite simply defining the pavement structure, including the material inputs to be used, and that's no different to what we currently do in pavement design. The second step is then in two parts. In this step, we're aiming to determine the strains under each individual axle in the traffic load distribution. Firstly, we calculate strains under both a single axle with single tyres and a single axle with dual tyres. So that still only requires the one circular run, except now two load types rather than just the standard axle are used, and the tech note defines the axle loads, tyre spacings and contact stress that should be used. Those strains from step 2A then are linearly scaled to give the strains at all load levels. And what I mean by that I'll show on the next page. So here I've just got a graph showing critical tensile microstrain up the vertical axis and the axle load for an individual axle along the horizontal axis. The top line, diagonal line, is for single axles with single tyres, and the bottom dashed line is for axle with single axle with dual tyres. So I've modelled both those two axles in circularly at loads of 53 and 80 kilonewtons, which you can see down the bottom. And from that ended up with two results, two critical strains, that 77.8 for the single axle with single tyre and 106.1 for the single axle with dual tyre.
Peter, so are we using the same tyre pressure for both of those standard load? Or?
No, it's not actually the same tyre pressure, so still using 750 kPa for the single axle with dual tyres. For the single axle with single tyres, it's 800 kPa, and that's all set out in the technical note. But that was based on that being the most common tyre from Michael's work that was being used in that axle configuration. So just getting back to the linear scaling, if we look at that 106.1 microstrain for the single axle with dual tyres, that was under an axle with a load of 80 kilonewtons. If we now go back to, say, 40 kilonewtons for that same axle type, going up to the dashed line, you can see that the strain reduces to half what it was at 80 kilonewtons. The reason for that is there's a linear relationship between the applied stress, or the applied load, and the resulting strain in circularly, or in the Austroads procedures as well. So that's why we only need to calculate the strains in circularly under those two axles at one load level each. We can then use the spreadsheet to calculate the strains under all other combinations of axle load. So the result from that process is a table looking something like this, which shows the critical microstrain for each combination of axle group type and load level. So down the left-hand side we've got the load levels in 10 kilonewton increments. We've then got a column for each of our 6 common heavy vehicle axle group types, and then under that we've got the microstrain, tensile microstrain at the bottom of the asphalt under a single axle. So it's not the strain under the complete axle group, it's just the strain under a single isolated axle from that group. The strains from this table are then used to calculate the allowable loadings using the asphalt fatigue relationship, which is the next step. So step 3, calculate the allowable repetitions of each axle group type and for each load combination. So that simply just means for each of those strains that we calculated on the previous page. So that could be done either using the shell relationship or the mix-specific relationship that Eric covered. Because the strain is under a single axle, the result we would get from that calculation would actually be the allowable number of individual axle loads, which is capital N. We actually want to know the allowable number of axle groups, so we add an additional term to those equations, which is on the next page, which is simply dividing the result from the previous page by the number of axles in the group. So capital N in that case will be the allowable number of repetitions of each axle group. So that calculation is repeated for all those strains that we've calculated for every combination of axle group type and load. The asphalt fatigue damage can then be calculated for each combination of axle group type and load. That's done by dividing the expected repetitions, which is our design traffic, for that combination by the allowable repetitions from step 3. And this is very much the same, or at least a very similar procedure to what is done for concrete pavements in the current asphalt pavement design guide. Those increments of damage are then summed to give the total damage, and this must not exceed 1 for the pavement to be acceptable in terms of asphalt fatigue damage. If it is greater than 1, we then go back to the start and maybe thicken up the pavement and repeat the process. That completes the assessment of the asphalt fatigue damage. The other aspect to consider is loss of surface shape, which is often called subgrade deformation. In the current Austroads procedure, the assessment of subgrade deformation is done on the basis of standard axle repetitions to the 7th power, so SAR 7. In the new method, it's not necessary to calculate SAR 7. We don't need to calculate SAR 5 either. So instead, the damage for subgrade rutting is considered in units of ESAs. So the performance relationship for subgrade deformation needs a slight adjustment to account for that difference between SAR 7 and ESAs. So pavement designers out there would know that the current relationship is N, which is the allowable repetitions, equals 9,300 divided by the microstrain to the 7th power, but that gives us N in units of SAR 7. Because now we're using ESAs as the unit, there's been a slight adjustment just to the number in that equation to 9,150, and that just accounts for the difference between ESAs and SAR 7. So the allowable loading then for subgrade rutting can then be compared with the design traffic, which would also be in units of ESAs. Yesterday I showed a comparison of asphalt thicknesses for a particular case, which was a motorway, using the new or the proposed technical note. This chart shows a similar comparison using the same full depth asphalt pavement structure, but in this case for a wide range of traffic loadings. And this is a really nice summary of how all the changes in the technical note sort of come together and what the outcomes should be. So we have total asphalt thickness up the vertical axis and the design traffic along the horizontal axis in ESAs. The top diagonal line there shows us the thickness of asphalt that would be achieved using the current 2013 pavement design supplement. The middle line shows the required thickness when the new multiple axle method is used. And I've also included in that line the upper limit on design traffic that Jeffrey covered yesterday at 200 million ESAs. So you can see there's a reduction in thickness typically in the order of 5 to 10% between the top line and that middle line. And that difference is something, or the savings, that should be achieved immediately with the new technical note, and that's even without considering the mix-specific aspects of the method that Eric covered yesterday. Optimising mixes for fatigue performance should lead to further reductions in thickness, somewhere below that middle line, and the bottom dashed line there is to illustrate just where that could be for the right mix if it's properly optimised for fatigue performance. Another interesting thing just to point out from this chart, if you look at the middle line, just where it levels off on the right hand side, which is at 200 million ESAs, which is 2 by 10 to the 8 ESAs. In this example, that occurs at a thickness of about 350 mils of asphalt. It's important to remember or realise that that 200 million ESA limit is on the assumption that this new method for considering axle loads is used. If we were using the current method, so the current Austroads method and the current method in the 2013 pavement design supplement, we'd actually hit that 350 mils thickness at a design traffic of about 1E8. So you can see from that top line where that crosses 350 mils is about 1E8 ESAs or 100 million ESAs. So for current pavement designers that are used to doing traffic the current way, it's best to think of the limit where asphalt thickness levels off at about 100 million ESAs using current methods. But because of the reduction in thickness that comes with this new method, that limit needs to be adjusted upwards, and it's adjusted up to 200 million ESAs to give the same thickness. So that's the end of that session. The next session I'll go into a bit more detail about the multiple axle method, just illustrating it through a worked example.
Great, thank you, Peter. We've received a couple of questions and comments, so we'll address those now. Firstly, I just wanted to point out to our audience that, yes, in fact, the presentation material and the recording will be shared with you, so there is no need to write down all those lengthy formulas. You can just wait until the conclusion of the webinar, and that will be shared with everybody. So thank you to those people who queried that. I've got a question here. How can designs be undertaken if there's no weigh-in-motion data available, Peter?
Yeah, so at the moment, using current methods, I guess if there's no weigh-in-motion data, designers will often assume factors to be used. It's going to be no different in the new method, so there will be the option, if there's no weigh-in-motion data available, to assume some values or assume a traffic load distribution, and we're working on some separate guidance to help designers come up with some assumed values, I guess, for different situations. So that information will come out in the coming months, I'd say. So there'll be a fallback position if there's absolutely no other data available which could be used for this method.
Good, thank you for that, Peter. Another question here from Stephen. So Stephen's saying, given the traffic loading assessment is based on performance under load, is there any intention to also look at the actual performance under in-service conditions for modulus and fatigue?
Yeah, certainly we would really love to do that. There's certainly challenges in budgets, I guess, research budgets, and getting the right project to do that, because it is a quite large and extensive research effort that will be required. We're actually working with the Gateway Upgrade North project at the moment on dig and deviation, which is one of the sections of road on that project, where we're actually hoping to get a trial or get a section of road where we're going to do that very thing that Stephen's asked about.
All right, thank you for sending that through, Stephen. Another question here from George. George is asking, or rather stating, that he understands that Brisbane City Council adopted values for modulus and fatigue values for multi-grade bitumen from independent modelling they've done. Have they been involved in discussions which has led to the development of the draft technical note, and are they likely to adopt this technical note?
I really can't answer that. I'm not sure.
I think the answer to that is that they're definitely aware of it, and I'm sure that they're considering it, but we're not, obviously we cannot speak for the Brisbane City.
They've certainly come. We've done a seminar on this same topic, and they were certainly represented at that, so they're well aware of it. So it'd really be up to them to make the decision about what they do about it and whether they adopt it or not.
Great. All right. Well, hopefully that's helped you out a little bit, George. A question from a different George this time, and the question relates to step 2A. Critical strains are calculated for two axle types, SAST and SADT, but how does that then work with the other axle types?
Yeah, so for the other axle types, say for example a triaxle group with dual tyres, so we're actually taking just a single axle from that triaxle group. So you would divide the total load on that triaxle group by 3 to get the load on a single axle from that axle group. So then you can scale the strains that you've calculated under the single axle, or that step 2A, for that single axle under the triaxle group. So we're breaking up all the heavy vehicle axle groups into individual axles. So we're considering all axles as being individual isolated axles. I hope that makes sense.
Hopefully that does, and George, you can let us know if that's clarified things for you a little bit more. And one more question here that we'll take for the moment before we move on with the next stage of the presentation, and that question's come through from Jin. Thank you, Jin. So it reads, how does the subgrade strength impact the overall design thickness under the new method?
Well, it's really no different to what we currently do. The subgrade strength is certainly a major input into the thickness design procedure, and in terms of characterising the subgrade and putting the properties of the subgrade into Circly, there's no different to what we currently do.
Alrighty, good questions. Thank you everyone for engaging with us, and Peter, I might let you then move on to the next stage of the presentation, which is on full depth asphalt pavement design example. So we look forward to that. Thank you.
Sure. Thanks. Yes, so I'll go through a fully worked example. This example is actually in the technical note, in the draft technical note, and we'll be sending out a copy of that as well to everyone. So the method is, or the example is fully set out in the appendices of that technical note. In this example, we use presumptive moduli for the surfacing and intermediate courses. So we're actually designing a full depth asphalt pavement. We'll use a mix-specific modulus and a mix-specific fatigue relationship for the base asphalt. And the example we're looking at uses a hypothetical mix for the base, which we assume has been optimised for fatigue performance. And we also use the improved method for the consideration of multiple axle loads in this example. Here's our design input. So it's a fairly heavily trafficked road, 70,000 vehicles per day, and 50% of those in each direction. 10% heavy vehicles. We've got a lane distribution factor of 0.65, design period of 30 years, a heavy vehicle growth rate of 3% per year. We're designing for 95% reliability. The project would be somewhere in southeast Queensland with a weighted mean annual pavement temperature of 32 degrees, and it's obviously a high-speed road with a heavy vehicle speed assumed to be 80 kilometres an hour. And another input which is not shown here in the slides, but we have a traffic load distribution, and that's in table E3 in the technical note. Before I start describing the thickness design part of it, we need to first calculate the design traffic in terms of the number of heavy vehicle axle groups, which is NDT in that formula. I'm sure the pavement designers out there would recognise that formula, which is straight from the current Austroads guide. So simply 365 times our AADT times our direction factor times the proportion of heavy vehicles times the lane distribution factor, the cumulative growth factor, and our NHVAG factor, which is our average number of heavy vehicle axle groups per heavy vehicle, which can also be determined from the traffic load distribution. So we actually know all those inputs, and we end up with a design traffic of 1.04 times 10 to the 8 heavy vehicle axle groups. So that's how many heavy vehicle axle groups we're expecting over our 30-year design period in the design lane. We use that design traffic together with the traffic load distribution to calculate the expected number of repetitions of each axle group combination and load level. That's done by really just multiplying the proportions in the traffic load distribution, which is shown in the background there, by the total number of heavy vehicle axle groups. We'll end up with another table of the expected repetitions. And I'll use that later on in the example, so for the moment we'll just park that, and I'll call back on that table after we've calculated the allowable repetitions for our design, for our pavement design. So now moving into the assessment of asphalt fatigue damage. The first step is to select the pavement structure and characterise all the materials. For our example, here's the pavement structure that we'll be using. We have a 50mm SMA surfacing and a 50mm AC14 with a PMB binder as the intermediate course, and we'll be using the presumptive master curves for those. I won't actually show that calculation, but it is shown in the technical note to give us the design moduli of 1300 MPa and 1500 MPa for those two layers. We then have a base asphalt, which is an AC20 with class 600 mix. In this case, I'm going to use the mix-specific master curve and the mix-specific fatigue relationship for that layer. And the asphalt's all sitting over the foundation there, which is a lightly stabilised, unbound granular improved layer with a bit of fill and a design CVR of 3% in the subgrade. The thickness design process is iterative, so we need to select an initial thickness for the base layer, which is what we're trying to solve. In this example, I've picked 230 mils for this iteration. So the first step, I need to determine the design modulus for that AC20 layer that we can use in Circly. So here we have the master curve. So this would have been determined prior to this by testing the asphalt mix using the procedure that Eric described yesterday. The master curve is simply defined by the sigmoidal function there, which is that equation, and all the parameters that go into that equation, alpha, beta, gamma, delta. In this case, the parameters are defined for a reference temperature of 25 degrees Celsius and the test air voids of 5% air voids. What we're really trying to do is solve that equation for the E star to get our design modulus. The only term we don't currently know in that equation is the FR, which is the reduced frequency. That's calculated using this formula. The reduced frequency equals the temperature shift function times the flexural modulus test frequency. So Eric showed this yesterday. The temperature shift factor comes from this equation, which Eric also showed. We know the A and B, which are part of our definition of the master curve for that mix. The T-ref reference temperature is just 25 degrees Celsius, and the other T there is the design temperature, which is the weighted mean annual pavement temperature of 32 degrees. So from that we can calculate the alpha T, which is the temperature shift. We can convert the heavy vehicle speed into the equivalent test flexural modulus test frequency using that formula there, which is just the speed divided by 2 pi. So now we can sum everything into the equation on the left hand side, and we end up with E star equals 3,749. That's at 5% air voids, which is the test air voids. I actually think one of the questions that we didn't get to answer yesterday was how you convert from the test air voids to the in-service air voids. In the new procedure, it's exactly the same as what's in the current Austroads pavement design guide. There's a formula in there for converting moduli to different air void levels. In this case, for an AC20, 6% is considered to be the typical in-service air voids for that mix type. So using the formula, which is not shown here, but it is actually shown in the technical note, and also in the Austroads guide, the modulus is 3,515 MPa at 6% air voids. And then we could actually use that in the thickness design, or more commonly we might just round that off to the nearest 100 MPa just for convenience. So we end up with a design modulus of 3,500 MPa. So that's the mix-specific design modulus for that AC20 base layer. Our next step is, will we input that pavement structure into Circly and determine the critical tensile strains under our 2 axle types that we've already mentioned, so under a single axle with single tyres and a single axle with dual tyres. So that was done using loads of 53 and 80 kilonewtons again, and ending up with those strains 77.8 and 106.1. So we then take those strains, put them into a spreadsheet, and we can calculate the strains at every other combination of axle group load and axle group type. Again, remembering that these are strains under the actual individual axles from the groups and not the whole group itself. So we then use those strains in the calculation of the allowable loadings. So step 3, determine the allowable loading, in this case using the mix-specific fatigue relationship. which is shown there. So we've got the relationship, we've got the C1 to C5 factors which have been determined using the method Eric discussed yesterday. ED is the design modulus, so 3,500 MPa for our asphalt mix. We're using strains under a single axle from step 2, which is the very last term in that equation. Because we want to calculate the allowable load repetitions in terms of axle group loads, we need to divide that total right-hand side of that equation by the lowercase n, which is the number of axles in that axle group. So that's converting from the allowable number of single axles to the allowable number of axle groups.
Just for clarity, Peter, does this mean you run this analysis for all the strain values from the table that you had in your previous slide?
Yeah, that's correct. So if I just go back to the previous slide, all those strains in that table on the right-hand side will be inputting into that equation on the next page. So this is very much something you need to do in a spreadsheet, because you'll be applying those performance equations multiple times to work out allowable loadings for every combination of axle group load and axle group type. Actually, here it is shown on this slide. So I've actually applied that equation from the previous slide into every cell within that table, and it's given us the allowable loading for every combination of axle group type and every load level. So we're now at the point where we can start comparing this to the design traffic, or our expected repetitions, which is that table there that we saw earlier in the presentation. The comparison is done by dividing the allowable repetitions, dividing the expected repetitions by the allowable repetitions. So, for example, if you just look at the under the columns SAST, which is a single axle with single tyres, we may as well just pick the first axle group load category there, 10 kilonewtons. Our allowable repetitions is 1.57 times 10 to the 12 repetitions. That's from the left-hand table. Looking at the same place in the right-hand table, our expected repetitions is only 3.75 times 10 to the power of 4. So we divide the expected repetitions, 3.75 times 10 to the power of 4, divided by 1.57 times 10 to the power of 12, and that gives us a damage increment for that combination. So we repeat that for every combination of axle group type and load level. And that's what I've done here. So now at the table on the right-hand side there is showing the damage, just the expected repetitions divided by the allowable repetitions for every different combination. The final step then is to add up the damage for every different combination, and that's shown at the bottom of that table. In this case we ended up with 0.99, which is less than 1, therefore the pavement is okay. So that term there, in CERCLI the term's the cumulative damage factor. This is exactly the same thing. However, as we're calculating strains for different loads and different combinations, we need to do that calculation separately in a spreadsheet. We can't get that damage factor directly from CERCLI.
So that means if the pavement is not okay, you have to rerun, well, redefine your pavement and rerun CERCLI?
That's correct, yeah. So in this case, obviously, I've done the iterations prior to this example, but if, say, that total was greater than 1, you'd have to go back, maybe thicken up the pavement or reconfigure the pavement structure and rerun the analysis. So it's not as onerous as it seems. You'd simply rerun CERCLI with the new structure, copy the 2 strains out of that into your spreadsheet, and then all the other calculations automated quite easily automated in a spreadsheet, and then you could check that damage factor again. So that really completes the assessment of asphalt fatigue damage. The final step is just to check the loss of surface shape or the subgrade deformation. So using the maximum vertical compressive strain in the subgrade. In this case we just use the strain under a standard axle. We sub that into the formula there on the left hand side, and the calculations shown in the technical note, but in this case the allowable loading was much greater than the design traffic, so there was no issues there in terms of loss of surface shape or subgrade deformation. So our final pavement structure resulting from that process is shown here in the middle column there. We've got our two 50mm layers of SMA14 and AC14 over the AC20. In this case, if you remember, I used 230mm in the thickness design model. I've now added 10mm construction tolerance, which is a standard thing we currently do and will continue to do. So our resulting pavement structure has 240mm of base asphalt, underlying that 100mm of surfacing in the intermediate course. For this example, I actually did a comparison as well with current design procedures, so the current Austroads guide and the current pavement design supplement, and using the presumptive shell relationship for fatigue and the presumptive moduli for all asphalt layers, including in the base asphalt. In that case I ended up with 295mm of asphalt. So there's in this case about a 55mm reduction in asphalt thickness, and about half that thickness reduction could be attributed to the multiple axle method, and the other half could be attributed to use of the mix specific fatigue and modulus for a mix that has been specifically optimized for those properties. So that's the end of the example. As I said earlier, that's fully documented in a lot more detail even than what the slides show in the technical note. So people should be able to work through that at their own pace to fully appreciate how the method works.
Great,
Are there
thank
any
you,
questions?
Peter. Yes, we've had a few questions, and I'll give you a minute to have a drink of water and just hand over to Eric or Jeffrey, in fact, if there are any comments you'd like to make at this stage.
Peter, actually, I got a question. So when we, come to calculating, making the two circularly run here, right? Using the 53 kilonewton and the 80 kilonewton. Given that we are going to linearly scaling everything, to the different low level, 10, 20, 30. Are there rooms to simplify? Rather than using 53, use 50 kilonewton in the calculation?
Yeah, the load that's actually used doesn't really matter because we're simply using that to calculate the strain at one load level. It doesn't matter what load level that is, and then using a spreadsheet to work out the strains at other load levels. The 80 and the 53 were, I didn't actually select those. They came out of Michael Moffat's work, and really they were just recommended because the 80 is what we, for the single axle dual tyres, the standard load for a single axle with single tyres. So I think we've just stuck with those because they're numbers that people are used to, but in reality you would get the same answer if you did change those loads. But I guess we want to be consistent with the approach that is likely to go into the Austroads guide.
Okay, thank you.
Great, thank you, Jeffrey. And actually, just because we're on the topic of spreadsheets, one of our audience members has asked if there is any plans to distribute spreadsheets to help with the new process. Is that on the cards?
Well, no, I would say we haven't really thought about that, but I think if you look at the examples in the technical note, it is really quite simple to set up these spreadsheets. So I think most designers should quite easily be able to set up their own, and they've got an example there to check their spreadsheets. So I don't think there's a lot of work in doing that.
Great. Well, maybe once we send out the technical note, if there's still any questions or concerns regarding that, you can perhaps touch base with our speakers. Would that be okay, Peter?
Yeah, that's fine. I mean, if people have trouble setting up their own spreadsheet, then by all means give me a call. I can help out there.
Great. Thank you very much. And a question here from Graham. So Graham's asking, would the calculations need to be rerun if the damage factor was 1.01?
Well, I guess the question is that greater than 1? I mean, that's fairly clear. I think that is greater than 1, so yes.
Alrighty, question here from Joanna. Joanna's asking, how many iterations did you go through to get the design thickness for the example layer?
Yes, Peter.
Well, I actually went through, I think I went through 3, and that was probably lucky. I think an average might be more, something like 5, or I don't know. It doesn't take a lot of iterations, and yeah, you're probably looking at maybe, it's going to be down to individuals and just how lucky you are, I guess. But
the more you practice, the luckier you get.
That's right, yeah.
No worries at all. Eric, don't forget to speak into your mic if you're answering, though. We want to hear you nice and loud and clear.
I'll probably just add to that. Adding to that, to do, say, 5 iterations probably is only a few minutes' work. It's really just changing the thickness in Circly, running that, getting the strains, copying and pasting those into the spreadsheet, and the rest of the calculations are automated in the spreadsheet. So you can see immediately whether that works or not, and then if it doesn't, just go back and change the thickness in Circly and repeat the process. So it's really only a few minutes work, I would say, for each design once you've got all the spreadsheet and that set up.
Great. Well, I hope that clarifies things for you, Joanna. Please let us know if it hasn't, and we'll talk more about that. Greg's also sent through a question, and that reads, what modulus did you assume for the lightly stabilised layer under the asphalt?
So I assumed a maximum modulus of 210 MPa. That comes from our current pavement design supplement. So that's the maximum modulus in the top sublayer. So that layer is actually sublayered into 5 sublayers as per the current Austroads procedures for unbound granular materials. And the maximum modulus 210 was used. I can't tell you exactly whether it reached 210. I can't remember. It may have been less than that, but it was certainly no more than 210. But it's just using the normal Austroads sublayering procedures.
Great, thank you for that question, Greg. And another question here from Stephen. How does the proposed process account for the influence of axles when they are in close proximity, I think that is, to each other and the zones of influence cross?
Yeah, well, the short answer is it doesn't, because we're modelling individual axles, so we're not taking account of any superposition of loads, I guess, from one axle to the next. That was certainly considered in Michael Moffat's work. That was the other option that was put forth, and it was decided not to go down that path, and I think it's probably best to refer to Michael's reports to get the full reasoning for that, because it is a fairly technical discussion about why we went for the single isolated axle approach versus the combined effect of individual axle groups. But that's all covered in Michael's reports, so I'd suggest Stephen refers to those.
Great. All right. Thank you for that, Peter. Much appreciated. And just a final question before we move on with the third stage of the presentation. Does the new method take long or much longer than the current method to complete a pavement design?
Well, the truth is it does take longer, but it really depends on what you mean by much longer. You know, is it worth spending an extra 5 minutes to save potentially millions of dollars? So, you know, we're only talking taking longer in terms of minutes, not hours or days or anything like that. So I think the extra effort is definitely worth it for the outcomes that can be achieved. The difference really is you're talking about milliseconds, I guess, to do the iterations in Circly using the automatic thickness method or the automatic thickness option in Circly. You're probably going from milliseconds up to maybe 4 or 5 minutes to do those iterations manually. So I don't think that's a major onus on designers to do that.
Well, I think to save millions of dollars, a few extra minutes of your time is a small price to pay, I would say. All right, Peter, thanks so much for answering those questions for us. And if you'd like to move to the final stage of the presentation, I'll hand back over to you.
Thanks. Yep. So the final stage of this presentation today, I'll just cover a few aspects that we haven't yet covered in the previous presentations, and also talk a little bit about the consultation process and how people out there can provide feedback on the technical note. It's fair to say that there might be some challenges and some risks in implementing the new procedures. As I mentioned yesterday, we're really on a journey. There's a number of controls that we've included to mitigate some of the key risks that we've identified in implementing the new procedures. So the technical note defines these mitigation measures, and we're quite openly saying that these are our ideas at the moment. We're quite happy to take other ideas and consider other ways of mitigating these risks. We're not necessarily saying we've come up with the best ideas, but we have put something out there for consideration. The first major risk relates to the use of the mix-specific parameters to determine the pavement thickness. Although the modulus and fatigue testing procedures are fairly well defined by the test method and also the technical note, we believe there's still some risk that those procedures could be applied inconsistently, and that could lead to inconsistent outcomes. And that could, of course, expose the department to poor pavement performance. And it could also unfairly advantage or disadvantage some asphalt producers. So currently the draft technical note proposes that the final modulus and fatigue testing for the mix-specific testing is to be done by an independent lab, and that would mean that would be done either by the TMR lab itself or by the ARB lab or a third party that's not connected to the asphalt company in any other way could do that testing. And then the results and the final curve fitting for the mix-specific master curve and fatigue curve would be submitted to TMR, and that would be reviewed through the normal mix registration process. The second major risk, which again relates to the use of the mix-specific modulus and fatigue aspects, is if the constructed mix significantly varies from the mix design. And again, that could lead to pavement performance being worse than expected. So what we've proposed at the moment is for additional compliance testing linked back to the mix design, and that's through resilient modulus testing or indirect tensile modulus testing, which would be undertaken at both the mix design stage, and then again there'll be tolerances on the mix design value. Those tolerances would then be used in construction, and that's a way of controlling any significant changes to the mix at the production stage. The third major risk identified is the risk relating to increasing the mix modulus, but at the detriment of fatigue performance. Mixes with wrap have certainly been found to fall into that category. Hence, the technical note requires that when the mix-specific modulus is used, the mix-specific fatigue relationship must also be used, and vice versa. It's not a case of picking and choosing one or the other. They both need to be used together. And the final key risk identified recognises that lab performance and field performance are really two different things, and we don't necessarily fully understand the relationship between the two for every situation. Better understanding of the relationship between the two is really needed for a wide range of mixes and pavement configurations. So I think we can comfortably justify some reductions in thickness by improving the fatigue properties of our mixes, but it's really unknown just how far we can push those reductions down without adversely affecting pavement performance beyond an acceptable limit. So we really need that better performance information to have a better link between the mix-specific design and actual performance in the field to close that gap. So on that basis, the technical note includes limits on both the allowable reduction in thickness that can be gained in full depth asphalt pavements using the mix-specific modulus and fatigue relationships. That reduction is currently set at 10%, but we're open to, I guess, discussion about that value. And that 10% reduction in thickness is on top of any thickness reduction that you would get using the multiple axle approach. And for thin asphalt surfacings, there's an in terms of implementation of the procedures for the mix-specific parameters in pavement design, this is how we envisage this to happen. Firstly, the asphalt contractor will develop their mix design, and more than likely they would do some modulus and fatigue testing as part of that process. The asphalt contractor would then engage an appropriate independent lab to do the independent modulus and fatigue testing using the procedures described by Eric and also detailed in the technical note. And that also includes fitting of the master curve and the fatigue relationship. The asphalt contractor will then submit those details to TMR, as is currently done with all asphalt mix registrations or mix design submissions. There was a question actually from Stephen yesterday I saw about the IP for the asphalt suppliers with this new process. So that is something we've thought about, and certainly we'll be engaging with the asphalt industry to talk about in more detail. We did think about including mix-specific parameters on the mix design register, which is included on the TMR website, so that would be freely available to anyone. But we did feel, and I think this really aligns with Stephen's question, that that would probably be commercially sensitive information that asphalt companies probably wouldn't want to be published so publicly. So our current thought is that the mix-specific parameters would be included on the mix design certificate for the mix, which already includes some of the commercially sensitive information about the mix. And then the asphalt companies could then provide that to the appropriate people in a more private way, I guess you could say, which is no different to what's currently done with those mix design certificates. So the mix design submission would be assessed by TMR prior to, if it's all complying, then the mix design could be registered. and possibly on the mix design registration list, which is on the TMR website, we could have some kind of tick box just showing a yes/no about whether particular mixes have been assessed or not through the new process. And that's something we need to follow up more with AAPA and the asphalt industry, just to get their thoughts on how that aspect should work. So once registered, pavement designers will then be able to use the details from the certificate to do their calculations, and that's as long as they know which particular mix is going to be used on the project. There's going to be many cases, of course, where you're just simply not going to know which mix is going to be used at the time the designs are undertaken, and in that case you would need to fall back to the presumptive values. So the plan now is to get feedback on the draft technical note. So we're releasing that today or yesterday for those who attended the seminar. Comments, the first beyond the 5th of October is really quite tentative and will largely depend on what feedback we get. It would be really nice to publish it this year, later this year, or even early next year, but we really just have to wait and see what feedback we get and what further work needs to be done to resolve any issues. In terms of providing feedback, a feedback form will also be circulated to help with you giving your feedback to us. Members of AAPA should provide their feedback through Rob Voss, and members of Consult Australia should provide their feedback through Stacey Rawlings, who's the Queensland State Manager. Their details will be on the feedback form. But internal TMR people in the districts, they can provide their feedback through their local representative on the pavement reference group, who are tasked with collating feedback from their districts. And all those representatives can send their feedback to me once it's all collated and agreed, I guess, in their areas. If you're not part of those major stakeholder groups, then you can also provide feedback directly to me. And there's my email there. So that's really the end of the formal part of the presentation. Thanks to everyone for listening, and I'm sure we've got a little bit more time, Angela, for some more questions.
Absolutely. We'll use the next few minutes wisely and take as many questions as we can. And just a reminder, so our presenter details are there on the screen. If there are any questions that we cannot address today, but they are burning, please feel free to touch base with our expert speakers and have a chat with them offline about those. Just a reminder that the presentation material together with the recording will be uploaded onto the NACOE website and will be shared with everyone here today. I hope you enjoyed today's session, and once again, if you'd like to review all that material, it will be made available to you. Before we take some questions, I'll hand over to Eric and Jeffrey to see if there are any thoughts they'd like to share at this time with our listeners.
No, Angela, I don't have any at this time. Thank you.
Nothing. All right, Jeffrey, if we have anything from you, I'll gladly hand over.
Computational stages, it's really not that much work. I put in the spreadsheet and it's quite straightforward. So I think it's something well worth spending time on.
Excellent. I'm sure that will become a lot more clear to people once they receive that technical note and can take the time to go through that. Okay, question here it's a two-part question from Stephen once again, and it reads, does the lab need to be NATA registered, and can you provide an order of cost of the testing to be undertaken? And then what about the risk of asphalt rutting as a result of pushing fatigue boundaries? Who'd like to take that one?
Yeah, I can answer that. Yeah, I think there would be an expectation for the lab to be NATA registered because, I mean, we require that for any other testing. I don't see why it would be different in this case. The cost of the testing, some rough figures, would probably be in the range of about $20,000 to $25,000 for a single mix. And I think, again, we need to keep in mind that the potential savings that can come from optimising mixes, so that 20 to 25,000 is really a very low percentage of a project budget. And
yeah, I think in terms of the cost speed, it will also very much depend on which laboratory will be running the tests. We need to.
That's right. Yeah.
I think that this creates a space for a commercial laboratory to enter the fray, and start providing the service.
In terms of the question about asphalt rutting, we're not making changes to the existing requirements for wheel tracking in the specifications, so those requirements will still stand. I don't think we're increasing the risk of any issues there by these changes.
Yeah, and I think that's actually a very good point. I mean, historically mixes in Australia simply have not been optimized for fatigue performance because there was no encouragement to do so in the specifications, and that's really one of the big changes here. It is very well possible to balance rutting and fatigue performance as well as the ME2 mix designs show. So I think that's really what we're after here, come up with real performance-based design of asphalt mixes that will lead to superior products, and that encourages the use of those in our pavement design system.
Steve, I hope you've got your clarification on those. Another question from Greg. Greg is asking, will you take filled cores from the pavement to check achieved modulus against lab modulus? Should the modulus from lab-made cores be the same as cores cut from the constructed pavement?
The answer to that is not as a matter of course. We have been doing this as part of this research program, and actually the Austroads report shows very well how well the modulus that is achieved in the field correlates to the modulus that's achieved in the laboratory, and that is really a function of the conditioning method that is part of the Australian design system. So laboratory specimens are conditioned to reflect what's happening in the field, and I think it's actually quite successful at doing that. So that is work that must have been done many years ago when they introduced that method of conditioning.
Great.
So the answer is we're not going to be doing that on a large scale because we're not doing that under the current design system either.
Alrighty. Well, thank you for addressing that question, Eric. If anyone else from the speakers has anything more to add to that, or we're happy to move on.
We'll move on.
Okay, lovely. Thank you for your question, Greg. Question here from Mark. Could a hold point be used in the construction specification to have the pavement design revised once? Have I lost you?
I'm just thinking about how to respond to that.
Okay, no worries. Would you like to take a moment to respond?
Maybe respond on how you see this implemented on a more general basis.
I think it's going to be different for different contract types. So for DNC type contracts, then really there would be no need for a hold point. That's just a matter of, that's the way the contract's set up. With the design and construction under the same contract, so it'd really be then up to the contractor to manage that process within their program. For other construct-only type contracts, normally where the design's done separately and then that project goes out to tender, normally there's the opportunity for the contractor to submit an alternative tender. So in that case I would see that the designs would be done using the presumptive values. The contractor bidding for that work, if they so choose, could propose an alternative tender, or they could negotiate even after they've won the job to optimise the designs during the actual construction stage. And that's often done for other changes, things like subgrade CBR testing, which will change the pavement thickness as well. Those sort of changes are already made, and I really see this as being no different to that case.
Alrighty, we've had a couple of questions from David. Now, David, well, the first part of David's question relates to the involvement of local government and specifically Brisbane City Council. I know you guys have talked about that already. But I think the short answer was, Eric, you were saying that Brisbane City Council has been consulted with.
Yes, and well, the Brisbane City Council is part of the consultation process, and they were definitely there yesterday at the seminar, so they're aware of it. Obviously, we're not going to speculate on whether they're going to adopt this or not.
All right, David, I hope that answers the question. And another question from David. The method requires 27 beams. How is it expected that the beams will be produced to get 27 identical samples?
Actually, that's a very good question, and we're actually not looking for identical specimens, because what we're looking for is in the normal or the natural variation in the asphalt properties that you would encounter with a mix. Fatigue testing it has an inherent massive scatter, and that's why we need 27 beams to be able to have the level of confidence around the results. That's why you need so many samples, and the aim is definitely not to create 27 identical beams. There's a certain air void content distribution that we're looking for, and that is perfectly allowable within the test method. So yes, and actually there's some space for contractors to be smart about how they produce their specimens as well.
Excellent. Well, thank you for those questions, David, and thank you, Eric, for addressing that one. Our question here from Philip. Philip's asking, how often will an asphalt-specific mix modulus and fatigue testing need to be undertaken for recertification?
Well, I think at the moment the mixed registration is on a 2-yearly cycle, so maybe this is something we need to think about more, but my initial thought would be that it would be on a similar cycle, but even saying that we don't necessarily require all testing to be redone every 2 years. It really depends on what changes, if any, have been made to the mix. So I think it's probably something that needs to be considered on a case-by-case basis. Certainly if the mix hasn't changed and none of the constituents in that mix have changed either, then I don't think we'd be insisting on repeating the testing too frequently.
Great, thank you for that question, Philip. One more question here from Stephen relating to global warming actually. Is there any risk with global warming and changes in asphalt temperature over 30-40 design life?
Well, I mean, I guess we all know the relationship between temperature and asphalt properties. The big question with global warming is really just what increase in temperature are we likely to have, and I think there's numerous models for global warming which give a wide range of possible increases in temperature. So I think as pavement designers, it's difficult for us to predict what those changes are going to be in the future. But I mean, that's probably I don't know if you've got anything more to add, Eric? Or?
Well, I think that global warming is more a risk to ice on the poles than it is to asphalt. But in general, if we think about that a little bit, we're designing for 30 years. Asphalt increases in stiffness over time, so that is one thing. So the modulus should go up, but also as long as there's no damage done. And the other side of that coin is as the temperature goes up, the fatigue performance of the material we would actually expect to improve. So I wouldn't be too concerned about that if we're really looking at only the technical aspects of it. I'm very concerned about global warming, but not for our asphalt items.
Great, thank you very much, Stephen, for that question also. All right, I'll hand back to our presenters to leave us with some closing thoughts, I suppose reflecting on today's presentation but also yesterday's. Peter, what would your final words to our listeners be? What's the take-home message today?
I think over today and yesterday we've been through quite a lot of technical detail. I know from listening to technical presentations myself, it's often hard to pick up all the detail through the presentation. So I just encourage everyone to look at the technical note when you get that and work your way through the worked examples. And I can almost guarantee that after you've done that yourself, a lot of what we said will be firmly stuck in your mind, and I think be very clear. And I think you'll come to realise that although what we're talking about is very technical, to actually do pavement designs using the new methods is really not that much more difficult than what we currently are doing.
All right, so the key message here is read the document and take some time to reflect on the presentation of today and yesterday, and much of it will become very apparent, I guess. Sorry, Eric, you were going to say something. I cut you off.
Yeah, so I think I would really encourage people to provide feedback. None of us in this room is claiming that we have come up with the best and optimum way of doing this. I'm sure there's improvements possible. So we're really interested in seeing how some of the practitioners would improve these methods. So we're really looking for feedback. And the other thing, again, something I said yesterday, but just to repeat, I think that some of the mixes that we need, or some of the materials that we need to really get this happening, we already have. It's really talking about people optimizing their EME2 mixes to be able to start using this methodology, and they can do it tomorrow. I think that's the main message from my side.
That's a great message. Thank you, Eric. And Dr. Jeffrey Lee, we haven't heard a lot from you today. Is there any message that you'd like to leave our audience with?
Well, actually, Peter and Eric pretty much sum up I think the closing comments. Yeah, again, I think we are at the start of the journey, so any feedback would be most welcome. And yeah, we are excited to see what feedbacks come through, and if you want to have a further discussion with any of us, just you have our contact details here in the slide. Yeah.
And I would also, one thing I would like to add is I would especially like to thank our listeners in Western Australia who've gotten up early for this. Well, some of them are listening, so that's yes. Thanks for getting out of bed early, guys. I wouldn't have done it. Anyway.
I'm sure the content was worth getting up early for, and I'm sure our listeners would agree, even those who perhaps didn't have to get up quite so early. Your time and effort to prepare the material today and yesterday was much appreciated to all three of you. Thank you very much. Please do take some time to reflect on the sessions of today and yesterday, and once that technical note is released, if there are any questions or further feedback, then obviously our presenter details are there on the screen, and they've stated that they're more than happy and willing to engage with you all on that. A couple of people from WA have said thank you for the acknowledgement, and thank you guys for joining us. Now, to those of you who took some time to provide us feedback in our pop-up survey yesterday, thank you very much. To those who didn't, we would still love to hear from you, to hear how we went. We do take the feedback very seriously, and really do appreciate you taking the time to leave that for us. So on that note, I will bid you all farewell. Have a wonderful and safe weekend, and hope to see you on more NACOE webinars in the near future. Thanks again.